Hi everyone, my name is Isiki. I'm a lecturer from Faculty of Electrical and Electronic Engineering. So in this video, I'm going to show you how to calculate the total charge. Okay, when you have been given a charge distributions. Okay, so you have a volume charge distributions and this has been given as this. Okay, rho v 5xyz nanocoulomb per meter cube. So this charge distribution exists in the region which is defined by these dimensions. Okay, so this is the range, okay, that you have these volume charge distribution and you have to calculate the total charge in the regions. Okay, so here it is rho v. So in order to get the total charge, we have to apply these formulas, rho v, okay, dv. Right, so next thing, we are going to define what is the suitable coordinate system for our dv. So we have three kinds of coordinate systems. We have Cartesian, we have cylinder, and we have spherical. However, based on the information given here, okay, x value, y value, and also z value, they are given. So here we choose to use Cartesian coordinate. Okay, Cartesian coordinate system to represent our dv. Okay, so for Cartesian coordinate, our dv, okay, will be equals to dx, dy, and dz. And you can switch the positions of these dy, dx, and dz. Okay, so the range has been given, so it is easy. So you just insert the range. So for z is 0 to 4. And for the y is -1 to 3. Okay, and also for the x is 0 to 2. So the rho v given is 5x y z nano. Okay, and then we have dx, dy, and dz. Okay, we have to arrange accordingly. So next is to perform the integration with respect to the x. So while we're performing the integration with respect to the x, the other parameter, they are all constants. So I will move it out. So I will move y, 5y, z nano, I will move it out. And I will just focus on these x. Okay. So now we can perform these integrations by using our calculator. Okay, we can use this, we can get a direct answer by pressing our calculators. So from the calculator, okay, the value is 2. Okay, so the value is 2. Alright, so we will continue the remaining integration with respect to the y. Okay, with respect to the y, and it's a nano. Okay, so now y and dz. Okay, so while I want to perform the integration with respect to the y, I will bring out all the constants. So 0, 4. So here I write down 10 z nano. Okay, so I will focus on the y integrations. Okay, so again, this part, you can get your answer from the calculator. Okay, so the answer will be 4. Okay, 4. So when I multiply 4 with this, okay, so I get 10 z nano. Alright, so and now we perform the last integrations, okay, which is with respect to the z. So I move out the 40 nano and I integrate from 0 to 4 z dz. Alright, so now we left the last step, okay, which is to use the calculator to find out the answer when you perform the integrations from 0 to 4 and you have 8. Okay, so 8 multiply with 40 nano, so you get 320 nano, and the unit of the charge is coulombs. Alright, so this is how we find the total charge, okay, on the inside these structures. Right. Okay, so in these questions, you have been given a line charge. Okay, so this is your line charge. Okay, so this line charge has a line charge density. Okay, line charge density stands for the rho L. Okay, it's 15 Z nanocoulomb per meter. And you have to find the total charge. Okay, so total charge means it is Q. So you have the charge distribution on the line. Okay, and you have to also find the Q. And this line is in the region. Okay, so this is the dimension of the line. Okay, is from -1 to 6. Okay, if we put this thing, okay, in a diagram, in a 3D diagram, if this is your Z, okay, oh sorry, let me draw again. Okay, so this is your line charge. Okay, so to calculate the total Q, we have to apply the formula, that is the total charge is equals to integrate the rho L dl. Okay, so dl, L stands for the meaning of length. Okay, if you want to know the length of this line, you have to refer to as this Z. Okay, so over here we will replace the dl with the dz. Okay, and then we insert the rho L. Okay, the rho L is 15 Z nano. Okay, and the length of the line, okay, is given by the questions from -1 to 6. Okay, so we have to do the integrations. Okay, so by moving out these 50 nano outside, so we integrate the Z dz. Okay, so from the calculators, okay, we can get the answer. So 6 -1, all right. Okay, so it's 17.5. Okay, so this is the result when you perform the integration, and you have to multiply with this 15 nano. Okay, 15 nano, so you get 262.5 nanocoulombs. Okay, so this is the total charge on this line charge. All right. Okay, now let's look at one more example, okay, to find the total charge. All right, so find the total charge. Okay, total charge. This is finding the Q on the surface of a sphere. If the radius of the sphere is 3 meter, okay, and the surface charge density, okay, is -7 R square nanocoulomb per meter square. Okay, so now your structure is a sphere. Okay, it's a sphere. So on the surface of the sphere, okay, there is a surface charge density. Okay, so they give you the rho x. So to find the total Q, you have to integrate the rho s ds. Okay, we have to integrate the rho s ds. Okay, so this is a sphere. So now, what is the ds that we have to use? Okay, so since our structure is a sphere, we have to refer to the ds of a sphere. So you need to flip to your formula sheet. Alright, so now let's look at the ds that we have. So we are now dealing with the cylindrical coordinate systems because the shape is cylinder. So we will zoom in this one. And there are 3 of them. Okay, there are 3 ds. So which one to pick? Okay, so it depends on where your surface facing. So your spherical surface is facing the r directions. Okay, it is facing the r directions. So we have to pick this one, r square sine theta d free. Okay, r square. So I will write down here Q equals to integrate the rho x is -7 r square. Okay, nano. Okay, then we have r square sine theta d theta and d phi. Okay, right. So let us insert the interval for the theta. So for sphere, theta is 0 to pi and phi is 0 to 2 pi. Okay, so now you need to integrate. Okay, you need to integrate the sine theta d theta. Okay, so I will bring out all the constants, r power 4 nano. Okay, so you integrate 2 pi, so sine theta, d theta, and d phi. Okay, so press calculator this part. Okay, so when you press calculator, you would get 2, right? You will get 2. So you will get 2 here. And when you continue pressing your calculator, okay, you will get another. Okay, that is, okay, you have 2 pi and you have 2. Okay, so given the r, okay, r is the radius, so radius is 3. Okay, so you can substitute it 7, 3 power 4. Okay, and then you have 4 pi and nanocoulombs. Okay, nanocoulombs. So you can multiply it. 4 pi, sorry, 4 pi. Okay, so 7 multiply. Okay, so you will have negative 2268 pi, okay, nanocoulombs, okay, on the surface of the sphere. Okay, right.